All right, cool. So deadline 6.1. It's the biggest, smallest. It's the biggest minor upgrade release we've ever done. 750 odd features and bug fixes. Majority of actually features, not bug fixes. Haven't got time, obviously, this afternoon to show you anywhere near as many as I would love to. So just going to show you the crop of the best, really. I'm going to show you asset and script dependencies, how deadline slaves aren't going to start jobs unless the assets, and by assets I mean they could be textures, cache files, whatever your particular data file, your plugin that you need to process is dependent on. It could be one or more Python scripts, so they're not going to allow the job to be released effectively from the pending state unless the script has returned a successful true statement. We're going to show you the brand new node-based panel, the new version of Draft and why it's so important for Jigsaw, which is our multi-region rendering for initially 3ds Max. There's some new increased scheduling control, even more customization in the way in which you allow your jobs to run on the farm. There's a secondary resource allocation, pools, another pool system, or is it another pool? I'll explain what I mean by that later. There's a maintenance job mode. It's been asked for quite a few times, and pleased to say that's now in, as well as additional cloud support in Deadline. There's the pop-up message notification system. Of course, the latest versions of lots of applications has been added, as well as some newcomers as well. V-Ray distributed bucket rendering initially for Maya and Max has been added. Very much a heavily asked for feature request from users, as well as two new APIs. There's a RESTful web HTTP API, as well as a standalone Python API. And last but by no means least is just yet more and more performance enhancements throughout the product, which you'll just benefit from. So assets and script dependencies. Jobs can now be dependent on an asset file or files, as well as one or more Python scripts. By default, it's completely empty, these lists, so it's no change there. But if you want a job to be dependent to ensure that perhaps some files that you need to process downstream or are available upstream, such as perhaps some CAD data files that you need processing, or some textures or cache files, the slave will not start the job unless those asset files exist and they're in a path location which the slave can actually visibly see and resolve. Same thing with Python scripts, but not just in existence. The Python script needs to return a success. So by that definition, we can write a Python script that actually returns failure and can perhaps do some query into a database, some proprietary studio production tool, check that something's in place to allow the job to then progress, i.e. To release it from the pending state. The slave is asset aware now, so this is effectively the new feature that wasn't in there before, and this obviously is really important when we start looking at the bigger concepts such as remote render farms and cloud rendering capabilities in the future as well. So let's go ahead and actually have a look at that in the monitor and see what that actually means. Just going to use a Mac monitor for some of the things today and switch into the PC Windows version as well sometimes. So what we've got here is we've got some asset render jobs here, some 3D asset driven jobs. Could be Max, could be Maya, could be any kind of plugin that we support really. It's got some frame dependency jobs as well queued up, but effectively these jobs are in the pending state. I'm just going to take them out of suspended state because that's just for me to just queue things up and just get everything ready. But effectively what we've got here is we've got some jobs here which are pending dependency and they're pending an asset. So if we just right click and look at the job properties, or we can double click, which is quicker to get into the job properties, we can see here this field here which is required assets. And what we can see here on some Windows paths Not a problem if you've got path mapping enabled as well for multi-operating system support, because those path mappings will then be manipulated. But we've got 4 textures in this case, which all need to be available effectively in my desktop in a directory called assets. I need to have some textures available here before the jobs will proceed. Luckily, you can see in my asset directory that all those 4 textures are actually available. So hopefully the job's going to pick up when the job pending scan takes place, which is automatic. So we just switch to Windows here and just start up a slave. I'm going to open up the log window on slave as well, just so you can actually see what's going on a little bit more under the hood. Let's just move this out of the way. So there, let's just open up the slave log. Of course, we could do this remotely and stream this. And what do you know, it's all done it very, very quickly. Let's scroll back up the log. Just going to open it up a little bit here so you can see. And the key thing here is the job has been released. Why is it being released? Well, the pending job scan has taken place. It's loaded all the jobs. It's worked out that actually there are some pending jobs. It's looked at the pending jobs and looked at the assets and said that those 3D rendered jobs which have some assets, required assets associated to them, all the assets are available for those jobs to proceed. And so it releases it in 349 milliseconds. And then you can see here, if I just close here, you can see here that the job in question is something to do with V-Ray, and so the job actually proceeds. So we can just shut that down for now. So let's just go back to Deadline Monitor for a second. So what we can see here is that those 4 jobs, as the log showed, have released them from the pending state into the queued state, and that's effectively required assets for you. Let's just suspend those for a second. Let's have a look at the idea of scripts. So very, very similar. We can just double click this time as opposed to right click and go to job properties. So previously we saw that you could put required assets in here. So similarly, we have a script section here as well. So we can add one or more Python scripts here, where we can identify a path location where they are, and we need the Python script to effectively return success if the job is to be released from the pending state. So we can let's just mark the job as pending now. The only reason it's suspended is just so that I can go through these different demonstrations with you this afternoon, one by one. Let's actually just go into a Python editor and just have a look at actually that get script dependency Python file. So all that needs to be declared is a main function, and in that we pass it the deadline job ID. So it goes through each of the deadline job IDs for each job in the queue, and we also just need to pass it the task IDs, of which we can just set that by default to a value of none. The reason for that is the idea that we may actually not want this job to be dependent in whole 100% and be released. We might actually want some of the individual tasks, i.e. frames, of the job to be released on a per task basis. If that's the case, then if task IDs doesn't actually return a value of none, then we can look at actually the individual frame, the task dependencies, and so we can selectively pass back an array that actually says, you know what, the first couple of frames, they can start being released now because the assets required for those first few tasks, they're actually now available, they're there now upstream, but the rest isn't available yet, so just hold on a second. You could see this in perhaps a simulation job that then has a couple of caching, baking jobs which are dependent, and you wouldn't want one to be released before the other, and you needed a script to fire in between before that release could take place. But let's just keep it simple here. Let's just, I don't know, let's just nonchalantly put in a value of a variable saying, is this webinar awesome? And then it's false. Well, actually, no, it's not. Let's make it equal to true. And so we return a value of true, which means it's successful. Let's just see that in practice. Let's start up slave on this machine. So we've got that job. It's in the pending state, the script-driven job in the queue. Deadline is going to go probably too quick for me, so I'll end up, yeah, it has. So great thing, you can just right-click, suspend the job log, We'll just scroll back up, and you can see again pending job scan. It's loaded up the jobs, seeing what may be pending, might need to be released. It's seen that there's a script. It's identified that the script is available on this path. And then the Python has actually returned, is this webinar awesome? Well, of course, it's true. So the job then gets released, and the job pending scan is complete. That is, in a nutshell, asset and script dependency in Deadline 6.1. So it all starts to get a bit confusing. Dependencies, interdependencies, frame dependencies, textures, assets, scripts. So the node panel has been introduced, and it's based on, I think, Box's Magma Flux library. That name may sound familiar to some of you from some of our other products, so watch out there. It can be used to show which jobs are dependent on which assets, which scripts are dependent on each other. You can drag and drop jobs from the from the job panel into the to the node panel. So let's just have a look at that and see how that works. So this is quite a big setup here. I've shown you the script job here. I've shown you some asset jobs here, which are actually dependent on these tile jobs, these draft jobs as well. So let's actually see how that looks in reality in terms of the interdependencies. Quite handy is the lock panel in Deadline. So we can rip out a panel here. We'll put it back in a minute, but let's just open this up so we can see what's going on here before we have this big old mess. And let's see what's going on here. Actually, you know what? It's not too much of a mess when we actually start to understand and see how everything is related to one another. So we can see here, yellow is the 4 assets that I previously showed for the asset dependency. Purple is the Python script, which, so that's the job it's depending on. It's this one here. That's the one that's queued, that's why it's white. So the suspended ones are grey. And then the dependent ones, which we can see here, are the orange ones. So the color coding is identical to the color coding on the left there, you can see in the job panel. But the great thing is that if we do need to change some dependencies, we can. If we need to get rid of this asset, we can easily select all its dependencies, so we can hit the delete key and we can kill it. Now this isn't going to change the setup of this particular job and this asset going into these 4 jobs immediately until we hit the save button in the top left hand corner. Alternatively, we can hit refresh, which effectively puts us back before we started tinkering with this node graph, because we might have done something a bit silly and killed all our dependency chains. Lots of little options available in here, such as the mini map, which can be positioned in different locations around the view. We've got a selection here, toggle selection here, which allows us to select once we've fully encompassed the nodes, or perhaps just once we cover over half of them. We have the ability to double click on a node and go into effectively the job properties. We've got some simple zoom controls here to allow us to pan around the nodes here, like so. We can actually, on really long job names, we can actually make sure that the width of all the nodes is identical, because we actually remove some of the text in the middle for any light. Perhaps we wish to position that to the left. It just means that all the nodes have the same width, which allows us to better visualize things. And of course, yes, we can connect up the jobs manually via the node graph, which allows us to build our own dependency chains exactly as we see fit. And then when we're happy, we can actually commit the changes by pressing save. We can also show more details, same details as in the job panel, and we can choose to perhaps show the frames. We can move the frames up the queue, click OK, and then you probably see all the nodes here just updated with the frame entry in them as well. On every single job, we don't even need to go into the job panel anymore. We've got all the controls available on the right-click menu here in terms of locking, saving, reloading the view, the functions I've shown previous, as well as the normal job menu controls which can be found here. We can also add a job as well, so perhaps there's a job that's in the queue, it's not even one of yours, it's someone else's job. There's there's a cinema 4D partitioning job or something, and we might want to move that in, and we may wish to then make that actually dependent on this node as well, and then commit the changes by pressing the save. Obviously, if we just unlock the monitor, oh, that was a bit too quick for me. There we go. Just unlock the panel. We can then easily put the node graph back into the monitor and keep it visually wherever we want it to be. And that's the job dependency view.